This animated diagram shows what happens to a home during the rainy season. Underground rainwater builds up around the perimeter, pushing horizontally against your basement foundation walls with massive pressure. To relieve that pressure, we need to extract the dead sump pump sitting in the basement pit and install a new unit to actively push that threatening water outside. Looking at the necessary materials, we have our replacement pump, fresh PVC pipe, a 1.5-inch female adapter, primer, and glue. You will also need a multi-screwdriver and a specialized PVC saw. The easiest way to bypass complicated plumbing modifications is to buy the exact same make and model as your broken pump. It allows you to match the new hardware directly up to your existing setup. Swapping this broken unit immediately is the only reliable way to get the water out before the trapped subsurface pressure cracks your cement foundation. Step 1 is disconnecting the old hardware. Use the multi-screwdriver as a socket to loosen the rubber bands holding the top of the old check valve in place. With the bands disconnected, pull the entire assembly, the pump, the pipe, and the valve, up and out of the flooded pit to work on it at the surface. This cross-section shows how a check valve operates. Upward water flow pushes the hinged flapper open, acting as a one-way security gate. Conversely, downward returning water pushes it completely shut. Without this, gravity pulls water back, forcing the motor to overwork. Because of this constant mechanical stress, keeping an old check valve while installing a new pump puts your fresh motor at severe risk of premature burnout. Extracting and replacing the valve alongside the pump guarantees both components age together, protecting the new motor from immediate damage. To prep the new pipe, we use a straightforward template technique. Lay the old assembled pump right next to the new POG run pipe and mark the exact cut length side by side. When you make that cut, avoid the common mistake of grabbing a standard hacksaw. It is very hard to keep a hacksaw blade perfectly straight on round piping. This comparison shows why the tool matters. On the right, the jagged, angled cut from a hacksaw. On the left, the flat, smooth edge produced by a dedicated PVC saw. Flat edges are required to form a tight seal. With a straight cut finished, apply your PVC primer and glue to attach a 1.5-inch female adapter securely to the fresh end of the pipe. Then take that newly prepped pipe and screw it directly down onto the threaded top output port of the new pump. Taking the extra time to use the correct saw and adhesive guarantees a watertight, highly pressurized column that will not leak back into your basement. Before attaching the check valve, look inside it. If your system uses 1.5-inch piping, you need to pull out the internal 1.25-inch rubber inserts that come pre-installed. Now we must avoid a frequent installation error, mounting the check valve upside down. Look closely at this exterior view of the check valve. You will see a large embossed directional arrow cast directly into the rubber. This arrow correlates directly to the internal flapper. It must point vertically upward, directing the flow of water away from the pump. Properly aligning this single arrow determines whether the machine functions as a high-powered pump or acts as an accidental pipe blockage. With the assembly complete, we turn our attention back to the dark, flooded sump pit for the final drop. You must locate the existing solid bricks at the bottom of the pit, or place new ones down there before lowering the hardware. A pump resting directly on muddy ground blocks its ability to suck in water. Elevating it on hard bricks allows free-flowing intake from underneath. Lower the heavy assembly onto these bricks and tighten the upper rubber bands to connect it securely. Correctly elevating the pump maximizes its intake efficiency and permanently protects the internal screens from clogging with bottom sludge. Now that the plumbing is secured, plug the heavy pump system directly into the basement outlet. Watch this view looking straight down into the pit. As the motor roars to life, the standing turbid water violently churns and rapidly drains downward. Notice the perimeter weep holes on the sides of the pit. As the basin empties, they actively funnel the subsurface ground pressure from under the house into the newly cleared space. The water level has plummeted, the horizontal pressure on the concrete has been relieved, and the home is thoroughly secured for the incoming rainy season.